Hello, this is Mr. Stansbury. I'm going to take you through the notes on proving lines are parallel. At the end of this, you should be able to say I can develop theorems to show that lines are parallel, and I can determine whether lines are parallel. Okay, so first thing we're going to do is look at number 1, and that says state the converse of each postulate or theorem. Same side interior angles theorem, alternate interior angles theorem, and corresponding angles postulate. So first thing we need to do is we need to know what each one of those theorems and postulates are. So here's what the same side interior angles theorem says. If two parallel lines are cut by a transversal, then the pairs of same side interior angles are supplementary. Okay, so since we're doing the converse, that means we need to take the opposite. We need to switch the two ideas because converse is the O, second letter in is O for opposite, right? So we're going to switch the two main ideas. So then now we should be able to say if the same side interior angles are supplementary when two lines are cut by a transversal, then that means that the two lines are parallel. Okay? So we can write that out. If the pairs of same side angles are supplementary when cut by a transversal, then the two lines are parallel. That would be the converse. Okay? Alternate interior angles theorem. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. So again, we're going to switch the two main ideas. Okay, so then that means we're going to start with this down here. So if the alternate interior angles are congruent when two lines are cut by a transversal, then that means that the two lines are parallel. Okay, so there that is written out. Two interior angles are congruent when cut by a transversal, then the two lines are parallel. Okay, and then corresponding angles postulate. If that one states if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. So then we would say if the corresponding angles are congruent when two lines are cut by a transversal, then that means that the two lines are parallel. Okay, so there's that one there. Okay, moving on. We're going to prove the converse of the alternate interior angles theorem. Okay, but before that, let's take a little short comedy break, shall we? Sorry, that one makes me laugh. That one's a good one. Anyway, all right, here we go. Prove the converse of the alternate interior angles theorem. So here's what they give us. Angle 4 and angle 6 are congruent. So that's these two here in this diagram. We're going to prove that line M is parallel to line N. Okay, and just so you know, the alternate interior angles theorem is if two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines have to be parallel. All right, so first thing, let's put in what we know. Angle 4 is congruent to angle 6. That is given, right? So since we know angle 4 and angle 6 are congruent, that means that their measures have to be the same, right? So measure of angle 4 has to equal the measure of angle 6, and that's because definition of congruent angles, right? Okay. So now, something else that we can come up with is that we know that angle 5 and angle 6 have to equal 180 degrees, right? So angle 5 and angle 6 have to equal 180 degrees, and that's because these two make a linear pair, right? Add those two up, and it makes a straight angle. So that there's our reason there is linear pair postulate. Okay. Now, since we know up here that measure of angle 4 and measure of angle 6 are the same, this measure of angle 4 right here, we can just substitute that in right here for this right there, and that would give us measure of angle 5 plus measure of angle 4 equals 180 degrees, and that's because of substitution, right? Okay, now we know that angle 5 and angle 4 measure of angle 5 and measure of angle 4 have to be supplementary, right? Because they're equaling 180 degrees. So angle 5 and angle 4 are supplementary, and that's because of our definition of supplementary angles, right? Oops. Undo that. Oh, sorry, I'm making a big mess of this. There we go. Okay. Now, the last thing we can do, now that we know that angle 5 and angle 4 are supplementary, we can say that line M is parallel to line N because of the converse of the same side interior angles theorem, and that's what we were trying to prove here. Okay, so if we have that angle 5 and 4 are supplementary, then we know that M and N have to be parallel lines, right? And that's because of the same side. That's because of the same side interior angles theorem, and so we figured out that since we had angle 4 congruent to angle 6 alternate interior angles, those are also parallel lines. So we're actually using one of our other theorems to prove this theorem here, and that's a really important thing to know, is that you can use other theorems that you've proven and other postulates and definitions and stuff, whatever you can use to prove what you need, you go for it. Okay, that's all there is for this here. If you have any further questions on this, please feel free to ask in class. Thanks.